this tutorial video, we will be learning about 4x4 Hermitian phase estimation. We will be doing the coding on Google Colab. Like we did in the previous video, we will be starting with the installation of Blueqat. Type the code, !pip install Blueqat in order to install Blueqat. Let us do it in Google Colab. Type the code that was shown earlier. And click on the play button to run the code. Blueqat will be installed after a while. Then go to Edit tab and select Notebook setting. Enable the GPU and save the setting. Quantum phase estimation. We will learn few things on quantum phase estimation of random Hermitian matrix. In previous tutorial, we calculated the eigenvalues of 2x2 Hermitian matrix. This time, we will perform the quantum phase estimation of a random generated 4x4 Hermitian matrix. Calculating eigenvalues of Hermitian matrices is useful for finding physical quantities in quantum mechanics. It has wide range of applications in fields such as quantum chemistry and quantum simulation. So let's go to the implementation. First, we import required libraries. In this time, we use G-Gate backend, and check the version of Blueqat. Here error occurred. If the import error occurs, then it means you didn't install G-Gate. To install G-Gate, we can run the following commands. After installing G-Gate, now we will import libraries. We will use the same code. Next, we make a random Hermitian matrix. Type the codes. The first method is to check whether the mat is Hermitian or not. Then next, method is to get an unitary matrix from circuit. Then next, make random Hermitian and returns the triplet of Hermitian, eigenvalue and circuit for making eigenvectors. This segment of code generate random eigenvalue. This segment makes Hermitian from them. This one checks whether it is Hermitian or not. Finally, this segment returns Hermitian, eigenvalue and circuit. Then, we will make a Hermitian. Type the code. After running the code, we will get the random Hermitian of H, eigenvalues and eigenvectors. We can make an eigenvector using theta, phi, lambda and U3 gate. Then, check HVEC is equal to EVEC. It means, EVEC is a pair of eigenvalue and eigenvector of H. The preparation is done. We will implement quantum phase estimation. We make the quantum circuit and calculate E by quantum phase estimation. First we have to install libraries of Qiskit and PyLaTeX. You can use this code that I am using to install them. After installing both the libraries, then only we can see the quantum circuit of quantum phase estimation. Type the code and after running the code we will get the quantum circuit of quantum phase estimation. Then, we make a function for calculating the eigenvalue from observed result. Next, type the codes. The first method is to run the circuit for quantum phase estimation and returning candidates of eigenvalue, and then next method which converts the measured result to floating point value. Now, we can perform the quantum phase estimation. Type the codes. In this method we run small to high precision for comparison, and here we display a number of observation of obtained eigenvalue. After running the code, we get the values nearby the true eigenvalue. Then, we calculate the second eigenvalue. Type the code and click on play button. Now let's calculate the third eigenvalue. Type the codes, and hit the play button. Finally the last eigenvalue. Thank you for watching this video.